I will use this example to teach you how to do polynomial division. I will also use this example to show how you can sometimes go further to answer other questions. On here, we have been asked, is x minus 2 a factor of the given f of x function? Well, if it is a factor, I know when I long divide it, I should get remainder 0. So let's, first of all, think about that. Here, this would be called the divisor, d of x, and then this is obviously our original function, f of x. In general, when you set up long division, specifically with polynomials, you will put your divisor on the outside of your division symbol. So we would do x minus 2 outside. Now notice that we're not missing any kind of powers there. In other words, our highest power on x is understood to be 1, and then we have a constant to follow that. Now with f of x goes underneath my division symbol. Notice there as well we are not missing any powers of x. We have an x to the third power, a 2x squared power, a minus 5x to the understood first, and then a constant. It is important that you have all your powers. If you don't, we have to put what we call placeholders. I will show you on a later example what to do if you're missing powers. Now, polynomial division we perform by first looking at the first term in the divisor and the first term in my f of x function. Basically what you have to do is think, what can you multiply by x to get you x to the third? Well, I know that my x term has only one x. My x to the third has 3 x's, so I'm basically missing 2. So if I were to multiply by x squared, I would be able to get my x cubed. From here, you must distribute this x squared term to however many terms you have in your divisor. So I'll multiply x squared times x, that would give me x cubed, and then also multiply x squared by negative 2. So that would give me negative 2x squared. Notice how my like terms line up underneath each other. In other words, I have my x cubes under each other and I have my x squareds under each other. Now this step, I would normally subtract the two values. Well, these are polynomial values. It's a little bit more difficult to do. So what I do instead is when I draw my line, I also change my signs on the second row of numbers here. So this x cubed would change to negative x cubed, and this 2x squared would change to a positive 2x squared. Now just combine like terms going down. So x cubed minus x cubed is going to cancel. 2x squared and 2x squared is going to be 4x squared. From here, I'm going to erase a little bit of my scratch work so we can see what we're doing. In long division, you would now normally drop down a number. Well, this is a little different than regular long division. Notice that there are 2 terms in my divisor. Well, I also need 2 terms in whatever I'm trying to go into down here. I see I only have 1 term. So you bring down enough so that you have the same number of terms here that you have here. Okay, once you've brought those values down, then we basically start all over. You want to look at the first term in the divisor, and then in this case, the first term here. What would you multiply by the x to yield a result of 4x squared? Well, I know that I'd need a 4, and then I have 1x in my divisor. I need x squared, so I'd have to multiply by another x. And so here, I'd need to multiply by 4x. Also notice up here in the piece that's becoming the quotient, y'all see we have an x squared term, and then the next term down is x. That's not a coincidence. So you have your powers being in descending order along the top. All right, we put down the 4x. You now have to distribute that 4x to both terms that you have in the divisor. So 4x times x would be 4x squared. 4x times negative 2 would be negative 8x. I draw a line and I change my signs. I always circle my signs so that I can tell these are the signs that I'm dealing with on that second line of numbers. Okay, go ahead and subtract. 4x squared minus 4x squared cancels. We know if those two don't cancel, there's something wrong. Negative 5x plus 8x would be positive 3x. Bring down your negative 6 so that you have two terms below, matching the number of terms in your divisor. I'm going to erase some of my scratch work here. And then this is where I start over. I look here, and I look here, and say what times x would give me 3x? Well, I already have an x, so all I need is a 3. So it would be plus 3 up here. Notice we have our x squared, our x, and our constant. So it's in descending order along the top. Take the 3, multiply by your x, and also multiply by your negative 2. So 3 times x would be 3x. 3 times negative 2 would be negative 6. Draw a line, change your signs. In this case, the 3x's cancel, as do the 6's, and you would have remainder 0. Now I want to talk about what has happened and basically what that tells us in relationship to the original question. The original question was, is x minus 2 a factor of this function? If the remainder is 0, then yes, x minus 2 is a factor of f of x. What would have happened if the remainder had not been 0? Then we would have answered no, x minus 2 is not a factor of f of x. All right, now it said if so, find the remaining zeros, or find the zeros of f of x. Well, we know if the remainder is 0, we know this is a factor of f of x, but we also know this is a factor of f of x. What we want to first do is we want to write our answer in the proper form. From a prior slide, we saw that when we got a division problem, we can rewrite it as f of x equals the divisor times the quotient plus the remainder. Well, f of x was the original function. I'm not going to bother writing that whole big long thing down again, but we divided by x minus 2. We got a quotient, and remember the quotient is what you have up here on the top. So there's your quotient, there's your divisor, and then down here is your remainder. The f of x is what you had originally underneath. We got a quotient of x squared plus 4x plus 3. So x squared plus 4x plus 3, and then the remainder was 0. Well, if the remainder is 0, we don't need to write it. So I'm going to come back and I'm going to erase that part. Now, you see what has happened is we've been able to write f of x as the product of two things. To find the zeros, we know we're supposed to set our f of x function to 0, and then see if we can solve by factoring, or using quadratic formula, or whatever method we know of that we can to solve. Let's see if we can factor this one. So the x minus 2 is already factored. This would factor as two binomials, x and x. I need factors of 3 that add to 4. That sounds like 3 and 1. Both of them would end up being positive since all our signs here are positive. So on here, x minus 2 being a factor means x equals 2 would be a 0. X plus 3 being a factor means x equals negative 3 would be a 0. And then x plus 1 being a factor means x equals negative 1 would be a 0. And so now, with that, I have been able to find the zeros of the original f of x function. Scroll back up to the top and let you notice something. This was my original function here. The only way that I know of so far to factor something like that would be factor by grouping, because it has 4 terms and it's a cubic type of function. If you were to try to factor that by grouping, it's not going to factor. So up to this point, we had no way to find the zeros of that particular function. However, now, if we've been given, hey, find out if this is a factor, and if we find it is a factor, this was something that we were able to factor and solve. So it basically helps us reduce, and it helps us do things that we've not been able to do before.